In this session, we are analyzing the 3SX supply chain attack. Our objective is to investigate a compromised communication suite and trace the execution flow of the malicious components hidden within a legitimate installer. Let's start the investigation. Initial trace analyzing the suspicious installer virus total. We begin by identifying the primary infection vector, the 3SX desktop application installer, by performing a hash-based lookup on virus total. We confirm high confidence detections for a Trojan. The trace shows that the installer is digitally signed, but the signature has been weaponized to deliver a secondary payload. Identifying the malicious payload and creation time analysis. During the extraction process, we identify specific binaries that do not belong to the original software's manifest. By checking the compilation and creation timestamps, we can spot anomalies that suggests these files were recently injected or timestamped to match to legitimate applications folder structure. Sandbox analysis and behavioral mapping. Next, we move to behavioral analysis using sandbox reports. We are looking for dropped files and process injection attempts. We observe the 3SX process spawning child process that attempt to modify system settings and establish persistence. Classic indicators of a multi-stage malware attack. Deep time DLL site lighting execution flow meter mapping code T1574.002. The core of this attack is DLL site loading. As seen in the lab, a legitimate executable is used to load a malicious DLL, specifically ffmpeg.dll. This technique maps to mitre T1574.002 allows the malware to run under the context of a trusted process, effectively evading standard detection mechanisms. Analyzing S2 infrastructure and network behaviors. Moving to network layer, we analyze the command and control communications. The malware beacons out external domains to receive instructions. We identify these as S2 URLs by inspecting the memory strings and network logs, revealing a sophisticated infrastructure used for data exfiltration. Cryptographic analysis, understanding the encryption used to hide its activity. The malware encrypts its configuration files and network traffic. By analyzing the code, we identify the usage of XOR and RC4 encryption routines. Decrypting these strings allows us to see it hard-coded S2 servers and specific commands sent by threat actors. Threat actor attribution identifying Appleos Lazarus group based on the unique ATPS identifiers such as the specific DLL site loading method and the overlap in S2 infrastructure. This campaign is attributed to the Appleos cluster, a subset of the North Korean state-sponsored Lazarus group. The level of sophistication confirmed this was a targeted state-led operation like complication, final takeaways. We have successfully mapped the entire infection chain from the initial installer to the final S2 communication. This lab highlights the importance of scrutinizing trusted software and monitoring for anomalous process behaviors. Thanks for following and this technical walkthrough.